Okay, so here's example number 3 from 8-1, and in this one we're going to be looking at something called like terms. So what we're saying here is that terms in a polynomial are like terms if they have the same variable and exponent parts. And this is important right here in big bold underline. Like terms can be combined, and that's going to be really important for stuff that we do in this chapter. So I'm giving you an example on the left here of things that are like terms because our definition says variable and exponent parts have to match. And in each of these examples, we can say, well, this has a variable of x and so does this, and they both have the same exponent, which remember in this case is x to the first power, and this one also has an x to the first power, so we're going to say that they match each other. Okay? In the second one, same thing, they both have the same exponent of 2 and the same variable, and in this one, even though there's a bunch of variables, they all match exactly, so we can say that these are alike. And everything that's on the right-hand side here are examples of things that are not alike, and for different reasons. In this case, the variables don't match. Example 2, the variables match, but the exponents don't. And in this one, we don't have all of the same variables. So even though we have an x squared here and we have an x squared here, this one has a y and this one doesn't. So we're going to say these are not alike because they're not exactly matching all of the variables and all of the exponents. Okay, so now we're going to take a look at why that's important. Okay, so this is important because we can combine like terms by adding or subtracting the coefficients. Okay, and again, I have in big bold letters here something's really important. Exponents do not change when we combine like terms. Okay, so when we take a look at these examples down here, okay, I'm going to say 5x squared and 2x squared are like terms because I would say the variables match, they're both x. The exponents match, they're both 2. So I'm going to be able to add together the numbers up front. I'm going to say 5 plus 2 gives me 7. I am not going to change the variable. Okay, a lot of people in this case want to call this x to the 4th. Okay, but remember, exponents deal with multiplication, and in this case, we are not multiplying. Okay, we are adding these together, and in this case, x squared counts as a label. We're going to say this is similar to saying 5 apples plus 2 apples. I would say 7 apples, and I'm not going to change the label when I combine those like things together. So it's going to stay as 7x squared because we're adding in between them. Okay? So the second example, same thing. I see xy and xy. Those are like terms. So I'm going to subtract, in this case, the numbers that are in between those and say 3 minus 9 gives me a negative 6. And I'm going to keep the label exactly the same. They both have an xy, so that's going to stay. Okay, in our last example here, we're going to have to scan through this entire polynomial and find things that are alike. So I'm going to look at this one and say I see a 12x squared here. I see another x squared showing up at the end, and so I'm going to be able to put those together and say 12 minus, remember this is x squared is 1x squared, so I'd say 12 minus 1 gives me 11x squareds. Okay? And then these other two terms, 9y squared, I don't see any other just regular old y squares. This is not matching because it's got an extra part x. Right? So I'd say 9y squared doesn't have any like terms, so it didn't change. And 3xy squared, same thing, doesn't have anything like it, so that's going to have to be by itself. It doesn't change at all. So I would say this is a trinomial now. It's a slightly simpler version because we were able to combine the x squareds and make it a simpler problem. Okay? So here's the last little bit of information in 8-1, and that is that this important idea that when we name polynomials, which is what the last video was about, that we can't name them until we've combined all of our like terms. Okay, so we take a look at this last example down here. We're going to say we'd like to name this, right, and put it in standard form, but we can't because there's like terms like this 3x squared and this 1x squared that I have to put together first. Okay, so let's put this together. Okay, I see if I'm scanning along this polynomial, the highest degree, since we're going for standard form, the highest exponent is 3. So I'm going to bring that down, negative 2x to the third. That would be first. I'm going to say these two, 3x squared and 1x squared, can be put together, and I'd say 3 plus 1 gives me 4 of those. Okay, so I have 4x squareds. Okay, I'm going to keep scanning, and I'm going to say 5x. Oh, and look, there's a minus 2x, so I can say 5 minus 2 leaves me with a positive 3 of that x to the first. And then this last term here, this 5, doesn't have any other constant terms that are like it, so I'm going to attach that on as well by itself and say plus 5. Okay? So if I'm taking a look at this example now, I see it's in standard form because I go 3, 2, 1, and then the constant term at the end. Okay? And I'm also going to say that I can name it based on its number of terms because all of those like terms are put together. So I'm going to call this cubic. Remember, cubic is because it's got a highest exponent of 3. And I'm just going to call this a polynomial, and that's because it has more than 3 terms. We said if something's got 3 terms, it's tri, 2 terms, it's bi, 1 term, it's mono, and anything over 3 we don't have a special name for, we just call it polynomial. Okay, so we've completed this one. It's a cubic polynomial. After we combine the like terms, we can do that. Okay, so here are your 2 checkpoint problems asking you to do the same thing. Write the polynomial in standard form. Once you've combined all those like terms, you can name it based on its degree and on its number of terms.